Moin, moin, Hamburg. Was ist los? You wake up and you're back on the boat, but you've landed on the other side of the river. The jewel glows brightly in your pocket. You know that you have something of great value. You step off the boat into the desert. You start walking, and before long, you're in a canyon. It doesn't feel safe, but you continue along. There's nowhere else to go. Again. Just before everything goes dark, you see a man in a hood, and then you wake up and you're in a cave. It's the man. He tells you about your past and your future. He tells you that we're all surrounded by a force, and that there is a light side and a dark side. Good parts and bad parts, if you will. You like listening to him, and as you listen, the cave starts to feel familiar, like a church. Douglas Crockford, everybody.
I'm reminded of the American president, John Fitzgerald Kennedy, who on an occasion very much like this one said, "I am a hamburger," with cheese and onions and the other things. So I'm going to be talking about the web. I've been talking about the web for years. I've been traveling around the world talking about what the web does well and what the web does really badly, and how we should do the things that are good and try to fix the things that are bad. And unfortunately, none of the bad stuff has gotten fixed. So I've decided after many years of this, I'm going to do it myself. And I'm going to share with you my plan for how I hope to accomplish that. But before I can show you my plan, I first have to give you an apology. I have nothing to show you. Nothing works, nothing's finished, nothing's written. There's nothing to a point where you can look at it and go, there's just nothing you can take away from this. And worst of all, if what I say is interesting to you, there is no way that you can contribute. And that's intolerable. That's unacceptable. There's no excuse for that. My excuse is that I was invited to speak on any topic of interest to me, and this stuff is really interesting to me, and I hope it'll be interesting to you as well. The reason you can't contribute is just that we haven't gotten far enough on the project that we're at a point where we can accept contributions, but I'm hoping that'll get fixed, but we'll talk about that later. So, the web. Anyone heard of the web? Anybody? A few hands go up. The web rode on top of some important innovations like microcomputing and the internet, and it took advantage of all of that stuff and has become the way the world communicates with itself. It's been an amazing thing. But it was not designed to do that. It was designed to be a system for exchanging simple technical documents between physicists. And it is doing all of the stuff that it does anyway, mostly because of the cleverness of people like you who figured out a way to make it work well despite its huge limitations. But it has problems. It's difficult to develop for, it's fragile, it's got all those problems. But the biggest one for me is the inadequacy of its security model. And this is important because we're now moving trillions of dollars through the web, and the web was not designed to move money. And it's dangerous and scary. Identity theft happens all the time. XSS attacks and other sorts of security problems happen all the time, and we need to fix it. You know, we're now seeing nations going to war by manipulating the web, and it's bad. We need to fix it. So One of the fundamental security problems we have is with passwords. We depend on passwords to defend a lot of what goes on in the web, and passwords do not work for humans. Passwords first came into computing with the invention of the disk drive. Prior to the disk drive, computers didn't have passwords. Even computers that were doing top secret military work, designing weapons and breaking codes, those machines didn't have passwords. They depended on guys with guns standing around the machines, making sure that nobody got next to it. But when we start doing time sharing, where multiple people can be sharing the same machine, it's now important that we figure out a way to prevent one user from getting at the information of the other user, and also to prevent people from getting access to machine time that they didn't pay for, which sounds like a bizarre idea today since machine time is literally free. But it used to be machine time was really expensive, and we defended it with passwords. And it worked, because it would be rare for any individual to have access to more than one time-sharing account. But when we start moving to personal computers and then to the internet, we now have a password on every site, and every site requires a different password, and humans cannot remember that much stuff. And so our security depends on something which humans cannot do. We're not competent at that. So RFC 1738 is the first place we see documentation of URLs. URLs were an important step forward. And in that document, there is a form of URL which contains a password which will be sent to a site in the clear. At least one of the authors of the URL, or of the RFC, recognized that this was a really bad idea. So he included the sentence, "The use of URLs containing passwords that should be secret is clearly unwise," an amazing piece of understatement. They knew this was a bad idea. They put it in anyway because they did not have anything better to offer, which is kind of sad, but that's the state of the art at that time. There were people who followed this advice or used that form of URL and very quickly found out why it was unwise. So that's where we start. So in order to figure out how to fix the web, we first have to take a hard look at what's wrong with the web. Now, many of you have never worked with any other information technology, so the web is all you know. And so what I'm going to say may be shocking and upsetting to you, but it's all true. So let's go. So the problems with the web, again, are its insecurity, and most of its insecurity come from its complexity. When the web was originally proposed, it was a very simple system, which was why it worked. The simplicity of the original web was amazing. But because its functionality was so limited, we've been adding more and more stuff on top of it, which has caused it to become an extremely complex system. And very complex systems are very difficult to secure. So let's look at the components of the web. First, we've got HTTP, the Hypertext Transport Protocol. In my view, it does three things. The first is it's a textual container of key value pairs. And it's barely adequate at that, although there are much better textual formats for key value pairs like JSON, for example. It does negotiation, which was something that was very important in the early days of the web, not so much now. Some of the early web browsers couldn't display images or couldn't display some of the newer formats like JPEGs. And so they could talk to the server and get an agreement on, well, what do you know how to display, and I'll try to send you something like that. It was important in helping the web establish itself, but now it's just a waste of bandwidth. And then it's a request-response protocol, that you request a document, you wait, the document comes back, you disconnect. That was fine for the original model of the web, but that's not how we work today. We have a web thing comes in, and it may ask for hundreds of other things, script files, CSS files, images, and so on. But this protocol says you can ask for one thing, and then you can wait for it. Then you can ask for the next thing and wait for it, which is hugely inefficient. So to get around that, browsers will open up multiple channels to the same server so that they can have several HTTP transactions going on at the same time, which adds a whole nother level of complexity. Also, it discourages applications in which the server might be initiating information, that the server discovers, browser, you need to know this. There's no way the browser can find out until the browser explicitly asks for it. That's bad. Then there's DNS, the domain name system. This was created in order to save people from having to remember IP addresses, which is a really good thing. Unfortunately, there's some problems with it. One is that the domain name system interferes with the trademark system. They're not compatible. And so we're always seeing fights and conflicts and weirdness happening because of this inherent unresolvable incompatibility. But worse than that, there is danger in DNS, that there are known attacks on DNS so that you can force someone to go to a site which is not where they intended to go. DNS is not trustworthy, and that worries me a lot. SSL, Secure Socket Layer, this was developed at Netscape in order to provide link encryption and authentication, which is really important. Unfortunately, the technique that they came up with for doing it is extremely complex, so complex that we are still debugging it 15 years later. It seems every month there's a report about another huge, important bug found in SSL. It's been 15 years. If it were good stuff, we should have it working by now. And we don't. That's really worrisome. One of the reasons why we don't have it working is because it's rooted in certificate authorities. The idea was that we can have assertions about the security of things, or the relationships between things, and express them in the form of certificates which can be validated offline, so that we don't have to be online in order to verify the security of something, which I don't think even made sense at the time that SSL was designed, but it certainly isn't true now. Everything is online all the time. So having our security based on something which is offline leads to revocation confusion and other things. But worse than that, we have this dependence on certificate authorities. The first certificate authority is VeriSign, a company in California. I don't trust them. I don't know who they are. I don't know what they're doing. If someone has a certificate from them, all I know for certain is that somebody gave money to VeriSign. Beyond that, I really don't know what that certificate means, and that worries me. From reading Wikipedia, I know that VeriSign has in the past issued bogus certificates, that they've been hacked, that they lied about being hacked, and still have not been forthcoming about what the consequences of the hack were. That's worrisome. But worse than that, there are hundreds of other certificate authorities that your browser trusts at the same level, many of whom have already been corrupted, either by criminal organizations or by evil governments. I don't trust this system at all. Then there's HTML, the hypertext markup language. Is HTML good or bad? Well, it depends on what you're doing. If you're creating simple technical documents, which was what it was designed for, it's really kind of awful. It's really fussy, it's hard to write correctly. That's why we invented markdown languages. Markdown languages are so much easier to write, they're readable, they're just great. Compared to HTML, they're just so good. Now, if what you're trying to do is deliver interactive applications over the internet, HTML is really awful. It was not designed to be an application container. It's completely misfeatured. Again, we've made it work. In a minute, I'll show you how we made it work, but it's not ideal at all. There's one of the things I dislike most about HTML is that it encourages a style of development called templating, in which you've got a piece of HTML with variables in it, and you will insert text to replace those variables. This is a really bad practice because it is the source cause of cross-site scripting attacks, which are the biggest security exploit that are in browsers. XSS attacks are an inevitable consequence of templating. I also don't like templating because it creates a particular mindset in developers so that every aspect, every layer of the system front and back, top and bottom, everything is focused at generating HTML. It's HTML all the way down, all the way through. And if you've ever worked in any other information technology, you know that HTML is suboptimal. But if you get into this HTML generation thing, you cannot think properly about how to do things. Everything is about going to HTML. And often you see HTML concerns going all the way back to the database. The third thing that I don't like about templating is that it's a trap. Because everything is HTML all the time, you will never, ever be free of it. You're going to be trapped in the HTML world forever. There is no escape. The document object model, or the DOM, is the API that the browser provides to JavaScript. I believe it is the worst API ever imagined. It's just really awful. It's the wrong level of abstraction. It's hard to use. It's buggy. It's not portable. It's just awful. It's also not secure, because if you can get access to any node of the tree, you get access to every node and the network and everything. It's just awful. There's CSS, which stands for crappy style sheets. CSS was designed to solve the problem of formatting technical documents. And it's pretty much okay at that. It's really bad at formatting applications, particularly in that it has very poor modularity. So it's possible for one component onto a page to interfere with other components, even if they're completely unrelated. There are certain layouts that it still can't do adequately. It's just a mess. Speaking of mess, there's JavaScript. JavaScript is a huge mess. It was invented in 10 days. It turns out you can make a lot of mistakes in 10 days. But it's why the web works. I believe that the web would have been abandoned by now had it not been for JavaScript. JavaScript is the universal workaround machine. Whatever is wrong with the web, up until now, we have fixed it with JavaScript. Now, JavaScript is a hot mess and is going to get messier because the standards process cannot fix the things that are wrong with it. All it can do is make new things that are wrong with it. So that's the forecast. That's what's going on with JavaScript. But the good news about JavaScript is that lurking inside of it is a really good little language. In that little language, it's functional and objects, and it's beautiful and elegant and great, and it actually runs really fast now. So, you know, I keep looking forward to the day when we replace JavaScript with something better. I have not seen that language yet. Most of the new languages that I see coming up are just revisions on old languages. Maybe slightly different syntax or slightly different mix of features. I'm not looking for the thing that understood what JavaScript got right and moved forward in that direction. All the new languages I'm seeing are kind of going back that way. So for now, we're stuck with JavaScript. So there are many who have recognized, as I have, what's wrong with the web and saw there is an opportunity here. We can put out much better technology and we can capture the web or displace the web. You know, Microsoft has tried it many times, so has Apple, so has Adobe, so has Oracle, and many other companies, big and small. In most cases, the technology that they offer is much better. But in most of the cases, the technology that they're offering is not open, because their intention was to make a proprietary trap and to own the web or to own the internet. And fortunately, they have all failed. Because I really like that the web is open. That is the best thing about the web, and I don't want to lose that. The other reason why I think they all failed was they didn't have a transition plan. Or they didn't have a workable transition plan. The plans that they came up with were to try to trap you. They were trying to make things easier for you to migrate to the new technology. They lost sight of who this needs to be easy for. And because they didn't recognize that, they didn't get there. So my plan is to upgrade the web. I don't want to change it significantly. I don't want to replace it. I want to upgrade it. I want to provide good stuff, but without increasing its complexity. I want it to keep doing the things that it does well, because those things are really important. But I want it to be able to do new things which we cannot do safely now because of the inherent security problems. So my metaphor for how to do this transition comes from high-definition television, HDTV. Just a few years ago, the world was on analog system. Anybody remember the PAL system? A few of the old-timers raised their hand. It was awful. And in the US, we had NTSC, which was even worse. And at some point, the industry decided, the television industry or the electronics industry decided, we want to go to digital television. And maybe another time we can talk about what was really behind that. The FCC, the Federal Communications Commission in the US, and Congress were watching this transition really closely because they were concerned that if the day and date came where analog broadcasting got turned off and digital broadcasting was all there was, you know, say on January 1st of some year, we make the transition, and on Super Bowl Sunday, a significant part of the US population can't watch the Super Bowl, there's going to be armed rebellion. So they were really, wanted to make sure it worked. So the transition to high-definition television was not good for the broadcasters because they had to pay a lot of money in order to buy digital broadcasting facilities and equipment and operate them concurrent with the other, and there was no additional revenue for having done that, so that was just all expense. It was harder for program producers because they're now having to buy new equipment and have higher production values. That's a cost, and again, their programming doesn't get any more money, so that was a loss for them too. The people that the transition worked for were the viewers, the audience, that they were able to make the transition without being aware that the transition was going on. And the way this happened was with a device called a set-top box. You could buy a set-top box, and in some cases, the United States government would provide you with a free set-top box that you could put on top of your TV set, which would receive digital signals and play them on your old TV. So for most people, they did not know at any instant if they were watching the old analog system or the new digital system unless they noticed that the quality is very different or it's now taking a long time to switch channels. Except for that, they didn't care. The channel numbers were all the same. The programs were the same. It just worked. So that one worked. So that's how I want to fix the web. So in this analogy, the set-top box is the helper app. The helper app is something that's been in web browsers for a long, long time. If the browser has to display something that it doesn't know how to display, or if it has to work with a protocol that it doesn't know, it can start up another program and give the details to that program, and it will then do that stuff. We haven't used helper apps in years. The browsers have integrated so much stuff, there's been no need for them. But that mechanism is still in all of the browsers. So I'm going to take advantage of that. I'm going to build an application which does great stuff and package it as a helper app. So you can then go and install it, and when you try to run the new protocol, that thing will run up and everything's good. Now, that will not work for a transition because there's no way I can convince the audience to install a helper app. That's not going to work. So I need a better plan than that. So this is my transition plan. Step one, I need to convince one progressive browser maker to integrate it. After we've released the helper app, you all will get to try it. I expect most of you will download it because you're internet guys and you'll want to check it out. And enough of you are going to say, yeah, I'd much rather develop on this than on that, and we'll put pressure on one of the browser makers to integrate it. Integration should be really easy for them. All they need to do is provide us with a rectangle that we can blow pixels into. We need to be able to get UI events, and we'll need to be able to send messages back and forth. That's all they have to do. So that should be really easy. So I'm expecting probably Mozilla, Firefox likes to do this kind of stuff. I think they might want to do that. Or possibly Microsoft. They've been looking for a way to get back into your good graces. They might want to do it for that reason. Then they need to convince one secure site, maybe a bank or a government or a healthcare facility that has tremendous needs for security and has been frustrated with the current level provided by the web, that they will take the stand of requiring their customers to use that browser with the built-in helper app in order to get to their secure services. Once we've had that and we can see it works, we'll start getting some momentum. Risk mitigation will compel other secure sites to follow. And pretty soon I expect we'll see all of the banks, all of the retailers, everybody who's handling money on the net will want to move into this mode, at least for the activities that involve money, if not everything. Then competitive pressure will move the other browser makers to follow because they don't want to give up their market share to Firefox or Microsoft or whoever does that. And then eventually the whole world will follow for the improved security and faster application development, and also user convenience. There'll be a lot of benefits for doing that. Nothing breaks. I'm not proposing that anything about how the current web works changes at all. So I'm not requiring any change in behavior of any of the existing establishment, just providing a new mode for the things that can benefit from that mode. I'm going to be making use of strong cryptography. I'm going to be using elliptic curve 521 for key exchange. I'm going to be using AES 256 for link encryption and SHA-3 for doing that SHA stuff, for doing the hashing. This is very strong cryptography. It's stronger than I need. I want it really strong because I'm really paranoid. And we know that NSA has put weaknesses into cryptographic algorithms specifically so they could get into them. Knowing that they have done that, there's been a lot of close inspection of these, and nobody has found the trick yet. So as far as we know, this stuff is still secure. Now, just putting strong crypto into a system does not guarantee you're getting a strong system. We've seen lots and lots of examples of systems that tried to use strong cryptography, which were still readily breakable anyway. So this is no guarantee that this is going to work as I expect, but it's a necessary step. There's a brilliant guy named Zuko who has a theory about naming systems. He identifies 3 desirable aspects of a naming system: that it could be human meaningful, that it could be securely unique, and that it can be globally decentralized. And he says that you can get at most 2 of these attributes in a naming system. You can't get all 3. The one that the web took was human meaningful, which are URLs, which are just borderline human meaningful, but they're working. I'm taking the other 2 instead. So I'm going to end up with URLs which are completely nonsensical to humans. In fact, humans will not be able to type them. They're just going to be outrageously awful. But they're going to be securely unique, and they're going to be globally decentralized, and that will allow us to build up our security. We're going to be using elliptic curve 521 public keys as unique identifiers. So we will not have any passwords. So that means all attacks, all phishing attacks which are trying to get your password, those will all fail in this new system because even the users will not know what their private key is. So there's no way they can be tricked into giving it up. Now these public keys, when they're encoded in base 32, they will be 105 digits long, which, again, is impossible for a human to type. So we're going to have to come up with other means for distributing these numbers. Instead of using HTTP or SSL, we're going to be using secure JSON over TCP. And I'm using JSON because I like it, and it works, and it's good, and all of those good reasons. And I love TCP. TCP is one of the smartest things ever invented. And the web makes very poor use of it. I want to make very good use of it. So we're going to be a full duplex protocol so that it's not the request-response thing, that the client can send as many requests as it wants, and the responses will come back as they're ready, or some of those requests may not require responses. And if the server has something it wants to say, it can just send it any time. So being full duplex, we can manage a much larger class of applications than we can over HTTP. This is what the URL is going to look like. The scheme is going to be web. I think the old web should have said web. They made the mistake of saying HTTP, which I think was awful. I mean, that doesn't make sense to humans. Why did they do that? So I'm claiming web. I'm not confident I'll get away with that, but for now, that's what I'm calling it. I got rid of the slash because that never made any sense, right? Why does everything have to have a slash? That's silly. And because I don't trust DNS and because I don't trust the public key infrastructure, all of that stuff is now explicit in the URL. So we've got the 105-digit public key, and we've got an IP address, which is either an old IP address, which is 4 3-digit numbers separated by dots, or the new IP address, which is now 8 5-digit numbers separated by colons. That, again, is on the limit of what humans can type. So this is not a friendly thing. Then at the end, there's an optional capability, which indicates what we're about to do or what's about to get exchanged. And that could be important. So there are lots of ways that this could get distributed. Because it's just a URL, it could travel on any web page. So you could go to a secure site, and they'll say, from now on, we want you to go to this thing. So they'll just give you the URL, and that's where you go from now on. Or you might visit your bank, and your banker will give you a card that has a QR code on it that has this information encoded on it. So you just take that card and you scan it, and now your device is locked into that. And we can exchange or share those credentials over all of the devices that you have. So from this point on, you never give a password or any kind of ID information to the bank. It always knows who you are. Everything is secure. There's no log on. You always recognize each other, which is really good. And the reason I'm doing this, again, is because I don't trust VeriSign and I don't trust the DNS system. Another way, and probably the most popular way of getting these, will be Google. I would trust Google. If I ask for some company and Google says, this is their URL, I will trust Google way before I would trust VeriSign, for sure. So because that URL is so ugly, we're going to have to provide a lot of software support in order to make it usable by humans. So we'll provide trust management services and pet names so that you can assign names that you like to these things so you don't have to try to visually recognize them, because humans can't do that. The trust management will allow you to keep all of your relationships out in the cloud, so you don't have to worry about losing them. As long as you've got any device of yours, you'll be able to get access to everything that you have relationships with. Our computational model uses something that we call a VAT. A VAT is a secure container that we can put some bits in and they can run, and they can't get out, and nothing else can get in unless it's as we specify. And it's much better than a sandbox. And VATs will be able to communicate with each other. So we can have multiple parties working together, but they don't have to trust each other, and they can be confident that they cannot be corrupted by the other parties. This gives us something that's called cooperation under mutual suspicion. And that allows us to have mashups that really work, where we don't have to worry about any of the parties in the mashup trying to get over on the other parties. And this is going to be great for doing financial transactions and for lots of other applications, things that we cannot safely do now on the web. This is the block diagram for the Helper app. It's a really simple block diagram. I've only got 2 blocks on it. The first one is a JavaScript message server, which will probably be Node.js. The other is, and that one will be doing the networking and the file I/O and running most of the application. Then the other box is where we do display and user interaction. And that's going to be using Qt, which is that wonderful framework that was developed in Norway, and it was part of Nokia for a while, but now it's open. And we're not going to be using the entire thing. We're just going to be using the display parts of it. It's a really nice model for doing development. It's hardware accelerated and all that stuff. It's really good. And it's also going to make it much easier to partition applications better, so that everything that involves talking to the database or the back end will be on the node side, and everything that's talking to the user is going to be on the Qt side. And those two things can communicate by passing JSON back and forth between each other. And we're finally going to get the thing straight about where the data lives and where the logic lives. So I think all of this together should make application development for you much, much easier and much more reliable. So we've got the old web, which I want to retain. The old web provides us promiscuity, which turns out to be a really good thing, that you can just go following links or following searches and not care where they end up taking you, because the browser can do a fairly good job of making sure that they cannot damage you, especially if you're running Firefox with NoScript, which I recommend everybody be doing that. You really want to have NoScript so that if you land on a site which is not where you expected, there's no way they can take control, which is important. So that promiscuity for making introductions, for discovering, is really important. But then I also want the new web, which is about commitment, that once I have formed a relationship with some other party, a person or a company or a government or whatever, that's really important, and I don't want anybody to be able to corrupt it or spoof it or break it, that we can now do that stuff reliably, so we can increase our confidence of what we can accomplish in the web, and everything works. So there's nothing new here. There's no new science. There's no new invention. The security model that I'm using here is called object capability security, and we've been looking at it for decades. I'm confident that this is going to work. We've already seen lots of examples of it. I'm just kind of taking that, cobbling it together with a couple of things which we already know work, and putting it into the web. And I think I can succeed where others have failed, because I'm not trying to replace the web. I'm just trying to add a new mode. And I think that's a small enough effort that we can be successful at it. So in the meantime, keep doing what you're doing. Don't wait for this, because it may never happen. My intention is that it happens, but you all know that the intention of a programmer is worthless, right? Everything we write, we intend, it's going to be great and we're going to get done on time, and it doesn't matter what we intend, right? Reality is different. And that's why I'm hesitating on this, because I haven't made enough progress yet that I can say with confidence this is going to happen. But I'm having a really good feeling about it. But until then, keep doing what you're doing. Don't wait for it. In particular, do not hold your breath. Anybody holding your breath? Stop holding your breath. Now is not the time to do that. So what I'm trying to offer instead is just a little bit of hope, that maybe there's a way that the web could get a whole lot better without a lot of expense or inconvenience, that this doesn't require that the whole world change at once, that we can do it application by application, page by page. When you or your clients are ready to move, we'll do it. Until then, there's no pressure. So that's it. So until next time, please keep calm in JSON. Thank you and good night.